What's up, guys? So 2.3, 2.4, here we go. So you can see I'm starting on page 32. Okay. The only real sticky note I'm talking about here is I just simply write know the layers. Okay. So basically, you can talk about like Earth's consists of layers. There's a real quick kind of definition of each of them. You can see all the bolded words in there. This picture down here, I really like though. Okay. It shows kind of the globe right there, then a piece of the pie coming out the top. So you can see there's the upper mantle, there's the lithosphere, there's the oceanic, there's the continental. Then you can see the lower mantle, the outer core, and the inner core. On the test, you're not going to be able necessarily, or you're not going to be asked to identify each one. It's not like, point to this one, what is it, kind of a thing. But you just simply need to know the structure of it, because, like, the way that earthquakes work is like the how the vibrations move is based on the type and of the crust that it's going through. So you need to know that part. Okay, moving on to page 33. This part down here near the bottom is a really great diagram. All I have on the sticky note is just an arrow because you guys need to know these plate boundaries. So you can see on the left hand side, you got divergent. Divergent means that they're moving away from each other. Like, have you ever heard of like the Mid Atlantic Ridge? The Mid Atlantic Ridge is basically making it so like South America and North America are moving away from Africa and from Europe. That whole thing is basically splitting apart from itself. That's a divergent plate boundary. Next one there, that's the transform plate boundary. So what's called a strike, slip, fault. So a lot of earthquakes happen because of this is occurring. It's because things are basically coming together. They got like one's moving one way, one's moving the other way. So eventually they catch on something, and when it cracks, that's when the big earthquakes occur. Next one is the convergent plate boundary. So it has two different kind of results from this. Either one dives under the other one, which causes magma to be pushed up. So that's why there's volcanoes right there typically. Or they kind of come together and then the pressure against themselves makes a mountain range occur because they basically are pushing against each other. So instead of just one diving and one going high, they both just push against each other and they rise into the sky. Their elevation increases. Page 34. So all I wrote there was simply mountains form. That's that continental collision I was just describing. Now, one of the things, I'm actually going to move this. Let's move it up there. One of the things, I like this diagram right here a lot. Okay? Because all the different rocks all come from magma. The only real difference between them is what process it goes through. So initially, it's magma and lava. You can see it cools and crystallizes, then it turns to igneous rock. So either a bunch of heating and pressure happens to that igneous rock and it turns into metamorphic, or a whole bunch of weathering and erosion, transport, deposition happens, and now it becomes sediment. Okay, lithification basically means it part of the lithosphere. It kind of becomes the top layer on the Earth, becomes sedimentary rock, and this can kind of keep on going and keep on going and keep on going. Sedimentary rock, if that gets a whole bunch of heat and pressure against it, then that becomes metamorphic rock. So you don't necessarily need to know the different types of them. Like, you wouldn't need to like do this exact picture on a test, but by having kind of an idea of how the whole thing works and how they're all connected to each other would be really good. So on page 35, you can see there's different pictures of each of them. So like when I was living in Vegas, a lot of the places I went hiking had sedimentary rock like this. Really beautiful. So moving on to page 36. I don't have any sticky notes on this one, but this picture I like, basically this geologic processes happen across deep time. This is kind of the thing I like here, is that a lot of this stuff has been happening really, really slow. Like you see, human population is growing really, really slow. The atmospheric carbon dioxide growing really slow. The erosion, meters per million years, is growing really, really, really slow. So basically, things happen really slow, and then humans come along and we really start to mess with stuff. And the thing they say in this diagram I like is the Anthropocene question mark, because basically, and it says it perfectly in this picture caption here. It says, um, these patterns have persuaded some geologists that we should recognize a new epoch in Earth history, the Anthropocene. Basically, like, hey, humans are really starting to cause a big shift in the world. We should consider this a different time frame of the world. So next one, page 37. We're moving on. As you can see, this now we're on 2.4, the geologic and natural hazards. So that sticky note there, I say majority of earthquakes we never feel. There's about 13,000 earthquakes per year. Now the Ring of Fire is what they like to call around the Pacific Ocean, and I'm confident you guys have heard this before. It's basically all around the Pacific Ocean. There's a whole bunch of volcanoes and a whole bunch of earthquakes happen all the time. That's the Ring of Fire. So some of the earthquakes, obviously we've heard of, and obviously we've felt, and there's a lot of casualties and whatnot. Here are some of the big ones. Okay, and you can just see just the magnitude size of these guys. They're massive, massive, massive earthquakes. A lot of them, like I said, we don't feel, so they're not very big comparatively. Okay, so now page 38. This diagram here, affluent societies are making buildings more earthquake resistant, which again is one of the other reasons why we don't feel stuff. A, because our buildings are kind of resistant to the big ones, which makes it so we feel less of the small ones. So volcanoes form along plate boundaries or from hot spots. So volcanoes, kind of going back to the Ring of Fire, okay, you can see they kind of go around. These are all plate boundaries here. And if I go back maybe 2 more pages, okay, you can see there's that edge of that Ring of Fire on one side. There's the edge of the Ring of Fire on another side. Where those plate boundaries are, there's a whole bunch of volcanoes, as well as hot spots like Hawaii. Okay, so now we're on page 39, by the way. So volcanic eruptions vary greatly from toxic ash to slow-moving lava. So like Mount St. Helens, when that erupted in 1980, that was the toxic ash kind of eruption. Like if Yellowstone erupts, it'll most likely be the toxic ash. Slow-moving lava, that's like Hawaii. Kind of like think of it as like the younger areas of the world. That's typically where the lava flows happen. Next page, page 40 and 41. I'll zoom out. Talking about our earthquakes rattling the earthquakes rattling Oklahoma caused by human activity. And this is a really interesting one because I'm going to zoom in on these pictures here. Okay, so you can see populations in Oklahoma are rising. But look, from 2009, 2010, 2011, 13. So basically, you went from 50 earthquakes, and then in 5 years, now you have 5,400 earthquakes. And it's really interesting to kind of talk about, like the human causes on the world. Like, we obviously talk about climate change and deforestation, stuff like that. But like literally, we're demonstrating here now. We're like messing with the geologic rocks and the geologic foundation of our Earth, which is real scary because we're basically mining stuff, which is taking out some of the bottom things that are used for foundation. So page 42. Now we're on the supervolcano, which is Yellowstone. Okay, if you've ever heard of a nuclear winter, it's typically because of Yellowstone. If that sucker explodes, that's going to be really, really bad for us. So I talk about here mass wasting and landslides are caused by human activity. Okay, we're really good at kind of going in and taking out, kind of like the root of the soil. Like today in our entry task was talking about the control group. If basically if there's no plants there, the soil erosion increases. We're really good at that stuff. Okay, tsunamis are a massive danger and they're much worse than earthquakes typically. The reason for that, an earthquake can hit a certain area and take down a few buildings kind of here and there, but a tsunami just absolutely comes in and just does massive, massive, massive flooding across a really large area. So that's why tsunamis are typically the most scary thing comparatively. Last thing I wrote here, 43, the natural disasters are becoming more unnatural because of human activity, or we are increasing the frequency of them by our actions. And kind of there's the debate of causation versus correlation. Like with the Oklahoma thing here, like if people weren't around in 5 years, would it increase that much? I don't think so. But the ability to prove or show beyond the reasonable doubt that it is humans, that's difficult. And so that's kind of the debate of causation versus correlation with stuff. So, like I said at the very end, natural disasters are becoming unnatural or becoming more unnatural because of human activity. Leave some questions so we got stuff to talk about.